Welcome to Lesson 6 of Colgate Viz Lab's Lessons in Autodesk Maya, a primer in Maya Fluids. In this lesson, you'll learn what Maya Fluids are, how they apply to various scenes, how to prepare and create a Maya Fluid simulation, and a basic overview of important categories in the Maya Fluid nodes. Let's get started. So, since you've probably been through the particles primer already, you'll understand that particles and visual effects systems in general focus on a system of interconnected nodes. With the particle systems, it was the emitter, the particle object itself, and the nucleus. Now, things are a little bit simpler with fluids, but they are used for a myriad of different objectives, just like particles. So for this lesson, I just want to give you a really basic overview, basic understanding of what Maya fluids are, how they work, and where you might find yourself using them. Just so you, if you do find yourself using them and you're trying to pursue a specific objective, you already have the basic overview of where to look in order to change certain things about your simulation. So, to begin with, just like particles, we're going to be working with the FX tabs here. So the FX over tab, which will change your settings up top, and your FX tab here, which will allow you to see a visual representation of your various solutions. In the past, we've worked with to add an emitter for end particles and to create an end particle emitter. Now we're going to be working with this tab here, this little sub-tab, the Fluids tab. And in there, we're going to be first creating a 3D fluid container with emitter. Now, that's the easiest way to get started with Maya Fluids. And now, I've already done this. So if you see, under your outliner, once you create with a fluid with emitter, you're going to get a 2 noded object. So you have the overall fluid node and then the fluid emitter node that is underneath it, that is parented to it. Visually, you're going to see a box with a little emitter in it that'll look similar to your particles emitter. Now, what is this box? Well, this is, I like to call this a cage, but it's basically the area in which your fluids will work. So, for example, just one moment to modify my visual display. And that is what you're going to see when you first render or first simulate a fluid. It'll appear at the beginning of things as a mist. That mist will rise based on the buoyancy of it to the top of this box and sort of dissipate over the top. This is because it's just the default settings that are on right now, but keep this in mind. The fluid cannot leave the fluid container, ever. It doesn't exist outside of the fluid container. You'll also notice, like I said, that there is an emitter in the center of this. So there's the fluid, which is the cage, and the emitter, which is the node inside the cage. These two things work together to create the fluid. Now you can see that you can, like with particles, you can move the emitter around. So you just sort of can adjust where it flames up there. So let's modify that, just bring it back to its origin point. And now over in the attribute editor and the channel box, you can see that there are two separate setups here. You have the fluid shape and the fluid emitter nodes. Today we're going to start with the fluid emitter because I feel like that's going to provide you with sort of a baseline, and then when we get into the fluid itself, it gets a little bit more complicated, more categories. So we will start with the emitter, the object within the cage. This emitter basically just chooses where and how your particles will spawn. Or I'm sorry, excuse me, how your fluids will spawn. So to go over some basics for this, We're going to start with a few categories here. The transform attributes, like I've said before, are just a universal set of attributes that are common to all objects in Maya, and the fluid cage is no different. You have the standard translate to move it around, the rotate, the scale, and if this were a volume emitter, if you can remember from the particles, a volume emitter is a shaped three-dimensional emitter that can be skewed and shaped and changed to suit your needs. You could shear it, which is to sort of smear it across the screen a bit. Now, getting into the basic emitter attributes, well, like particles, fluids have various different types of emitters. Surface and curve, like last time, we will ignore for now just because they are very situational and it just depends what you're attempting to go for. However, in a basic self-contained fluid simulation, you will be using primarily omnidirectional emitters or volume emitters. So to begin with, we have this omnidirectional emitter, and as you've seen, it produces fluid on all sides, which is then taken by the statistics of the environment, the settings of the environment, and then dissipates upward. The other type of emitter, as you can see here, is a volume emitter. Now, if you saw the particles primer, you should know that this looks pretty familiar, and that's because they share the same shapes. And additionally, they share the volume emitter attributes category, although admittedly it's a lot smaller in the fluids setup. So you can switch between a sphere, a cube, a cylinder, a cone, and a torus, just like last time. And additionally, just like with particles, you can scale that in any random amount of non-uniform ways, and that applies to all of them. You can also do the volume offset, and with certain ones you can do the sweep change, which will it's sort of like cutting the donut or cutting the orange kind of thing, depending on what sort of shape you'd like. You can just sort of customize it all over the place. Now, directly below the emitter type, we're going to be skipping over this for now, but you have the rate, which is basically the rate at which the fluid is produced. It can get quite frequent if you increase it, but it just, for the most part, the default is 100. You'll notice that it's a rate of percentage now, not particles per second. That's just because this is basically one sort of globular mist. It's not individual particles. It's simulated in a way similar to particles. So like, for example, if I showed you the non-shaded version, you can see that there is sort of a particulate here. However, it is treated as one mesh, one mass, one being, as opposed to a host of tiny little particulates. So, moving forward, the next area that I'd like to show you is going to be, actually, nothing else here. So the next area I'd actually like to show you is going to be in the fluid container itself. So just to summarize quick, this is the fluid emitter. You can change it between omni and volume if you want to modify various things. You have a max and min distance for the omni, by the way. You can change the rate, you can change the type, you can customize the volume emitter all you want, but that is the fluid emitter. And you can have, I'll remind you, you guys can have multiple emitters per fluid cage, and they will all follow the same fluid rule here. However, it's just useful if you want to have more than one point emitting smoke, for example, over a range, you can do that. So that's the fluid emitter, and now we'll move on to the fluid itself. Okay, so here's where things get a little more interesting. This is the fluid shape node. This is, I guess, what you'd call the cage. This is, I guess, equal parts nucleus and particle object, if we're talking comparison to particles, they sort of fused those into this cage that not only is the particle, but is the physics of the or not only is the fluid, but is the physics of the fluid as well. It's basically everything but the emitter. So there's a few categories I want to show you guys today, just to give you a basic overview. We won't cover everything, but we will cover everything you need to get started. So let's begin. The initial tab here is what's called container properties. This is pretty important. This is always going to be your jumping off point when you start. This is because it contains things like boundaries, size, and base resolution. Now, when you start with a fluid, you're going to want to set a base resolution first. Usually when doing things like fire or water or other fairly complex subjects, I like to go with a base resolution of 50. It's not so high that it's going to crash the computers at the Viz Lab, but it's not so low that you're going to get crap visuals when you go and try and simulate something. So as you can see here, I'm in a non-shaded view right now. It just sort of shows the particulate. Shifting to a shaded view, you can see you get a nice, even smoke. You can get, a basic difference in density. You can see the sort of smoothing that's going on here, and yet it's not so bad that you're going to wish that you had a faster computer. Now, it's also worth mentioning that when you go to produce your final product, you may want to up the resolution in order to get that quality that we're looking for at all times. However, for testing, for tweaking, for initial work, and even for mid-range work, you're going to want to use the base resolution of around 50 to 60, maybe 70 if you're feeling ambitious. So something else to note, when you up the resolution and lower it, you'll see that the grid changes to represent that resolution. This is because fluids, by their nature, are a voxel-based effect, which is to say that, well, just to clarify, a voxel is basically a 3D pixel. So it's a little cube, and this cage is filled to the brim with cubes. You can't really see them because then you couldn't see the fluid inside. However, if you choose to change the display at any point just to show that, you will be able to see that this thing is laced, bottom to top with cubes of this resolution. So this is just a visual representation of your base resolution changing. The start default should look something like this because it's 10, so you can see that it's 10 by 10 by 10. I like to go with 50 by 50 by 50 for the reasons I've talked about already. Now, once you've done that, what else do you need? Well, let's say you want kind of an odd size or just a bigger size. You can scale if you like. However, just take note that it might not produce accurate simulations at certain sizes. Alternatively, you can, if you want to size it specifically without shearing your, or without smearing your voxels, which can happen if you scale non-uniformly, you're going to want to increase the size. Here, you see I've increased the size on the x-axis, and you actually get a you keep your square voxels even though one axis is longer than the others. So when in doubt, you probably just want to use size to increase your resolutions and that sort of thing, or rather to increase your axes lengths and things like that. However, if you do want to scale, just make sure you scale uniformly with that center square there. That way you will maintain square voxels and thus an accurate fluid simulation. After the size, we have what are called boundaries. Boundaries basically make it so the fluid can't escape this trap here. And not only can it not escape, it treats each little wall of this cube as exactly that, a wall. I like to use all of the boundaries for the most part. However, it just depends on what you're doing. Occasionally, if you're working with something that emits smoke but should not have smoke curling back on itself, I like to turn off the boundary of the positive y-axis in order to allow smoke to escape out the top. So, for example, you have none, both sides, negative axis side, positive axis side, and wrapping. For the most part, you'll want to work with the first four. I tend to use just X and Z, yes, Y, only negative Y side, which will produce something like this. So you can see you're getting that nice smooth resolution you want. However, you're also probably noticing that it's taking longer. That's absolutely fine. And see there, you can see the fluid is actually escaping. It won't exist outside of the cube. Nothing can break that law. But however, as it flows upward, it flows as though it was escaping the cube. That's what boundaries are for. Moving on to our next sub-tab, dynamic simulation. Dynamic simulation is another important tab because it covers things like various effects and things that can affect fields that can affect the fluid in general. So most important of these obviously is gravity. Set it at 9.8 like you physics students should know. It basically just set at 9.8 normally. And therefore you can sort of see that the gravity is flowing up, is just sort of allowing the fluid to drift upwards normally. Create the negative value here. You can see that gravity slowly takes hold of this fluid and brings it down towards the earth. And then it'll spread out on the bottom of the cage instead of up on the top. Now, a few other things to note. Viscosity is sort of the resistance to dispersion. So if you make something that's very thick, very viscous, it's going to stick together like more of a glue, like more of a thick paint, as opposed to a mist. If you make it even thinner, it's going to end up like a mist, like we have right now. Friction basically says when you brush a fluid against an object, how much is that going to slow its dispersion and its diffusion throughout the area. Damp will lower or raise, depending on its value. Basically, if you increase damp, you are going to find that your fluid will not disperse as easily. And it'll certainly take a lot more time. As you can see here, it is slowly succumbing to gravity, but because I've increased that damp, it is taking longer to disperse, and it will take an extremely long time to fill this container. Now, solvers and things like that, for the most part, we just don't want to deal with. They're for high-end tweaking. The high detail solve, it's mostly used for like really complex roiling smoke. You can leave it off for the most part, but if you're working with like really dense, really thick and swirling and complex smoke in high resolution, you might want the high detail solve just to get that extra little bit of detail. But as I say, that's something that's going to increase your render time, so that's up to you. The start frame is basically the start of your simulation. You can set that to whatever you like. I like setting it to a negative value, and just because it makes it easier for me to charge up a fluid, like say a torch. It makes it easier for me to light that torch and then start the scene after the torch has been lit and going for a little bit. So that's just the start frame, stuff to keep in mind. The simulation rate scale is just going to be set at 1 for the most part. If you want a simulation to go a lot faster or a lot slower, you can increase or decrease that. Try not to set it to 0 ever, because for the most part you'll blow up the world. No, just kidding. You'll actually just make your simulation not happen. So very low number, good for a really slow thing. Very fast, good for something that's got to be gone like that. So yeah. Now the rest of these are mostly just bits and bobs. They don't touch forward advection. They have various uses here, but basically don't touch that one. Conserve mass just says that after a fluid has been emitted and the emitter has halted, the amount of fluid that's in the container will always maintain and conserve its amount of mass. It won't expand past the laws of physics and fill the whole container, even if there's only a wisp of it, etc. It's got to maintain its mass no matter how thin or thick it is. Use collisions just means that it will collide with objects. Use emission you don't want to touch. Same with use fields. You can just leave those on. They're just used in sort of niche categories. Emit in substeps you can just leave off. Our next important section, however, is going to be the auto resize. This is used in particular for simulations that need space to breathe and want to maintain a level of high resolution throughout, while also keeping your computer not from straining too much. So, like, let's say we turn on auto resize. You can see immediately a number of settings open up. You've got max resolution being the most important, I suppose. That's just the highest the resolution of the cage will get, because with auto resize, it will morph and change in resolution just enough to keep the fluid simulation going. Dynamic offsets, you don't need to worry about. Your auto resize threshold and stuff. For the most part, you just want to turn this on and set a max resolution. You use auto resize primarily to work with simulations that need space, that you just want to let have free reign and simulate the best they can without being stuck in the box, while at the same time having the box around it. So just to show you an example, so let's say we emit this. The box is going to maintain size even as the fluid expands. So the longer I let this go, if the simulation were to continue along this timeline, let's say we set this to maybe 1,000, the longer this simulation continues, the more resolution is needed to maintain integrity, and the bigger and bigger and bigger the fluid is going to get, because the emitter is emitting constantly. So that's auto resize for you. For the most part, you want something that diffuses and disperses really quickly if you're going to use auto resize. Otherwise, you run the danger of bogging down your PC. Just set that max resolution, turn it on, and watch it go for the most part. If you need it, you need it. If you don't, you don't. Depending on what your objective is, it should be pretty self-explanatory. Now, we don't really need to tweak this over much, but self-attraction and repulsion, the whole section is basically dedicated to whether a fluid is going to be attracted to itself in terms of will it remain as one object, or is it more likely to sort of shred and diffuse really quickly. It's just another way to adjust that. Now, a big important section is what's called contents details. This is sort of your bread and butter section. It's going to be where you spend most of your time in terms of tweaking the initial fluid and what it looks like. Excuse me. So it's, I mean, it's such an important folder that it has subfolders. The most important one, I suppose, or the most important ones are density, velocity, and turbulence. Temperature and fuel and color, all of those rely on systems that we're not going to cover in this overview. And if you get into some really high-level visual effects, feel free to look those up. They can add a level of realism to your VFX, but they're not something we're covering here. So, first of all, we have density. The density is basically how dense, how visible, how thick is your particle. So as you can see here, we've got this sort of diffusing mist. Well, let's say we want to make that thicker, more visible, more substantial. You can increase the density scaling to make it more or less visible and more or less transparent. Buoyancy is going to be basically, is the object or is the fluid heavier than air, or is the object, excuse me, is the fluid heavier than air, or is the fluid lighter than air? That's buoyancy for you. A 1 value will make it lighter than air by default. However, we have inverted the gravity here, so the -1 value should give it a positive buoyancy. And there you have it. You can sort of see that it's starting to drift upward. The more buoyancy you give it, the more likely it is to sort of just fly out of there. However, I got to keep in mind the negative axis going on here. See, now it's moving at quite a rate upward because I've given it a high negative buoyancy in a negative gravity setup. You can tweak those back and forth all you like. but one affects the other. Bring it back to a default of 1. Dissipation is just the rate at which a fluid is dissipated into the air around it and disappears. It's kind of like a lifespan under particles. However, it's a little more vague here. Like, you can't quite tell when every little bit disappears. However, if you increase the dissipation, your particle or your fluid is going to disappear at a faster rate. This is going to keep your processing time really low if you have a high dissipation. Diffusion now is not to be confused with dissipation, because diffusion is basically the rate at which this mist or this whatever you have as your fluid will disperse into the cage here and just sort of fill it up with an average level of mist. For things like slime, you want no dissipation at all. For things like a torch with some smoke billowing off it, you want that smoke to disperse pretty quickly unless it's thick black smoke. So just depends on what you want. Moving on to the velocity section, you have the velocity scale, which just basically just modifies the speed at which your fluid moves around. You can scale that up or down. It's not a hard value, but it is a scaled interpretation of the base value of 1. So if you want to scale that per axis, feel free, but basically what it does is it allows you to scale how fast your fluid moves in any given axis. Swirl will create little whirls and rivulets throughout your fluid. If you want like billowing smoke and stuff, you might need some swirl in addition to our next tab, which is turbulence. But it just allows you to create more of an organic look as opposed to just a thin, smooth thing. It's the difference between like a rushing, billowing smoke and the smooth sort of smoke that drifts upward from a recently burnt out candle. So it's just all in the subtleties, really. Noise will create more of that sort of fuzziness within your smoke, sort of a jitteriness. It's just basically whatever kind of tweaking you want to do. Now, turbulence is going to be the ultimate in jitteriness. It will actually create a sort of whirls and eddies and like odd puffs and differences in your smoke cloud, in your fluid in general. If you want something smooth, don't use turbulence. Strength is the amount at which it is shifted. Frequency is the rate at which it is shifted, and speed is the basically the difference in velocity that is acquired through that turbulence. So that's about it for the contents details. Moving forward, we have something called output mesh. I'm not really going to do too much with this section, but I'll just tell you that output mesh is for times when you want to actually create a polygon mesh with a fluid. If you ever run into that situation, come to output mesh to change whether you want a quad, tetrahedron, etc., and you'll be able to see what your fluid looks like as a mesh. If you want a quick way to determine that, you can also do something like this. Instead of a mist, it will come off looking like a slime. This is useful for things like milk. You ever see those cereal commercials? This is basically where they're getting it. You can do a soft surface render or a hard surface. It all just depends on what you want it to look like. I prefer for the most part with surface renders, I prefer the hard surface. But as you can see, if I... There we go. So as you can see, I've sort of shown you here the grid that is created when you have this fluid in a surface form and in a volume render. But the surface render is going to rely on this output mesh here to determine what it's actually built from. So now if you're looking for that like low poly look, you can use, for example, like quad mesh. I'm sure that looks really cool. Like if you just go back to the shaded view, you can see it's all jagged and crazy looking. I don't personally like that look overly much. I prefer things like triangle mesh, which, allows for the sort of more organic, liquidy kind of look. There's also tetrahedra for pretty much, there we go, for a lot more detail and a lot more density, and acute tetrahedra, which, as we all know, is the tetrahedra you should ask to the ball. No, the acute tetrahedra is just their thinner angles, basically. So there you can sort of see it. The triangular sections within the tetrahedra are acute angles. So you can change the mesh resolution from here, and if you're getting too much of a resolution, and you could do with less in order to speed up render times or processing times, for example, you can change that here, and there's the result. So we're going to go back to the volume render and to the smoke itself. Further customization for fluids here, you can find there is a transparency. Do keep in mind that if you have a surface render, you are going to want to turn off transparency, because otherwise you will get that weird sort of overlapping semi-visible, semi-invisible state that you had before. Like, give it just a sec, that, because then you can see through it, and you might want that if you're rendering jello or something, but otherwise you don't really want that. So I'm going to leave it on for the mist's sake, but otherwise you don't want that. Volume render. And now moving forward, the next section is just glow intensity. You guys should be pretty familiar with glow at this point. It is one of the more fun things to use when working with lighting setups. You can also use that here on your fluid. So if you have a glowing green jello, you need a little transparency, an acute tetrahedra setup for a soft surface, and go nuts. Then you have a slime monster. Drop-off shape basically just says when it reaches the edges of the cage here, what shape is it going to form. You can use sphere, so it's a sphere within the cage. You can do cone. You can do all sorts of different shapes. For the most part, I like to use off or cube. But it just depends on what you want. If you have like a swirling mist orb, then circle, or then sphere is the one for you. Just depends on what you want. Now the next section is going to be color. This is just the base color of your fluid. You can change it however you want. I like to, if I'm doing mist like this, sometimes I like to use color that is based around a gradient or based around the density of the mist, which at this point it's a pretty uniform density, so that's less exciting. But if you give it a two-tone color, you can sort of see there you go. You can see the differences in the density, and that can add to your overall quality. You can also use an X gradient, which you can see is just sort of X to X. You can use a Y gradient or a Z gradient, whatever you like. There's just tons of options here for customizing the color, and this is a built-in ramp shader, so you can add as many colors as you want, twist them all around, and pretty much taste the rainbow, so go nuts. The incandescence section, just a reminder, incandescence is an object's reactivity to light when exposed to light. So this is just the ramp for incandescence. This is not actually the color. Color would be up here. However, you can adjust that based on things like temperature and density, and it just determines where you want your light to shine the brightest on an object. Now the opacity is something you'll find yourself altering a lot. It's just sort of how visible is your product here. You never want a full, a full opacity segment. That basically creates a full box that doesn't accurately reflect the simulation. There are times for it, but this is not one of them. So you basically can adjust based on anything. I like adjusting based on density and then providing a certain map. There are specific maps you can use for fire that are more accurate, for water that are more accurate, for a certain type of cloud that are more accurate. And when you get into specific discussions and objectives, you'll be able to see those. But for now, the basic ramp will do for us. So, additionally, in these color incandescence and opacities, you'll see this thing at the bottom called input bias. This is just another sort of slider that tweaks things, like, for example, like you get to that point where you have the right color ramp, but it's just not quite covering the segment you want. So you can adjust that, and it'll sort of slide up and down this Y gradient or whatever you end up using, and it'll give you just that little bit of extra tweaking that you need. Same thing goes for the shiny parts in incandescence. Or the opacity scaling, so you can just make it even, it's just a little fatter than the standard ramp would allow, or a little thinner than that ramp would allow. It's just another tweaking point. And finally, we have lighting and render stats. These are the last two that I'm going to cover for this. Lighting allows you to add a sort of a primitive light to your scene that's built into the polygon, or into the fluid cage. For the most part, you just click. You can do self shadow so that there's actually some shadows in here amongst the mist. You can add different lights, different ambient color in the scene. You can change the type of light. Usually directional is the default. You can put a point light in there somewhere and then specify its location. You can add a brightness to it, an ambient brightness in the place, a diffusion of light throughout the room, and the direction from which the light is coming. If you change it to a point light, you can specify where in the cage that light is. So, pretty self-explanatory and very similar to basic lighting setups. It's just a little bit of a tool that allows you to just sort of tweak the lights in there if you don't want to add lights of your own and you just want independent fluid simulation that's visible. So. Finally, we have render stats here that just says, does this fluid cast a shadow, receive it? Is it primarily visible or just secondarily? Is there smooth shading involved when you render it? Is it visible in reflections or refractions from glass? And that's really about all you need to know with that. There's also the standard visibility, rendering information and things, but they're not really important for working with fluids. But that is about it. That is the basics of Maya Fluids. You have the container and you have the emitter and the fluid in between. As you move forward, you'll no doubt run into situations where you have to create a specific type of thing. Feel free to refer back to this at any time. Otherwise, feel free to talk to Joe, and he'll send you to our Digital Tutors, now plural site website, which will allow you to gain some more knowledge. If you go there, feel free to enter Maya Fluids, and you should get a pretty lengthy tutorial. You can even do things more specifically like fire, water, explosion, you name it. And there should be a specific tutorial that will adjust these and help guide your adjustment of these to create, pretty much any effect you can imagine. So, hope you guys enjoyed the primer, and thanks for watching.